And, with this scratch limestone.
Yeah.
You know what the hardness of it is?
3.
That's right. Yeah, very good.
This is Dr. Paige Twiss, fellow docent of ours, and he is the former head of the Kansas State University Department of Geology. And he's going to help us today learn a little bit about the prairie geology.
Maybe. He's been retired since 1995. You think I remember anything? What is this?
Most of it.
What was that department?
So Paige, you're in charge now. We'll just walk up the hill.
You want to go clear to the top and
You can
work
stop
your way
wherever
back,
you
or-
want to, and we'll listen
All
to
right.
what you have to say.
Okay, well, what
Questions are welcome, I've been
Yeah.
told.
you understand how geologists do classify rocks, or use the names when you see them out in the field, the basic unit that we use to
No, I do
called a
not.
formation.
Okay.
And a rock that you're interested in is one that is uniformly homogeneous. You can trace it because of its thickness, because of its content, and its lateral extent. And the basic unit that we use is called a formation. Cottonwood limestone is a member of the Beatty Formation. Now, we use geographic names and rock type names for this. So the Beatty Formation, or Beatty Limestone is called, is a little town of Beatty up on what,
199?
199, what's the
36.
36, yeah. And that's where it was first described. Somebody worked down around Council Grove, and that became the Council Grove Group. And the courthouse at Council Grove is made out of what? You happen to know? You've been down there? Made out of the cottonwood limestone. Now, the units in the plains like this are kind of peculiar because they're relatively thin but laterally extensive. Now, the cottonwood limestone, which you know here, which is this bush line up here, is 6 to 8 feet thick. You can trace it into Nebraska. It goes down as far as Greenwood County in Kansas, and then it begins to get messed up with the stuff that's eroding out of Arkansas and Oklahoma. But it is laterally continuous, 6 to 8 feet thick. It, as you know, if you've been out very much, it's essentially 2 layers. The upper layer contains fusulinids, those little things that look like wheat grains, which are actually foraminifera. And the lower part is a little bit more massive. Sometimes there's a little bit of flint. It's not very continuous. It doesn't occur like the flint in, say, the 3 Mile, which is up above. And the 3 Mile has very massive 3 or 4 bands of chert that are about, or flint because it has enough carbon impurities in it, so it turns out to be gray, or in some cases really black. And that extends laterally. The upper unit, the Florence, which is the highest unit we find here, has anywhere from 15 or chert. And the ones in the Florence are pretty unusual in that they're not, you can't trace them very long distances. If you could see 3 dimensions of that, like you can over the Milford Reservoir, you could find out that that's really a real estate development area with a whole bunch of condos sitting up here with layers here, and then you got pathways going down to the one below, and then another pathway down below, so that there's an intricate system of chergits, which tells us that it's probably biologically formed. Same debris of fossils in the chert bands as you do in the limestone. So it means that at some time after the limestone was partly consolidated, then the bands of chert probably existed. The unusual thing is that the flint is silica. It's really quartz, but it probably started out as opal, which is silica gel that has a high degree of water in it. The more water it is, the lower the refractive index, which is a measurement that we use for opal. And quartz has a very high one, and opal has a very low one. The opal is not very well organized. It consists of little small globules that are stuck together. And then as it gets older, it loses its water, it gets harder, it gets more organized into a crystalline structure. Okay, and yeah, there's a good chunk. And it's kind of interesting because you've got a red center in there, and what would cause the red color?
Iron.
Iron, right. And then there's a darker zone over there which says that it must have a layer of fairly, a little bit of organic material in it, which is carbon. And then the flint has been close enough to the surface so that it's reacted or weathered, so that it's been kind of bleached, and you've got sort of a white color. And so you've got quite a bit of activity in here. Now, why is this there? Was it a cavity in the rock at one time? Why did it get into this unusual shape? And I don't know, and I don't think anybody else knows, but you can postulate. The origin of chert or flint has never been worked out.
Head up the hill.
Yep.
Didn't you say at one time there were probably about 20 or 30 different theories on the origin of flint
Yeah.
floating around?
Sometimes called varicolored. Very, very colored right here. But if you go up toward the top of this, you find alternating layers of green and red. And one of our graduate student years ago wondered why we had all these different colors in these varicolored shales. And he found out that the green is iron which is not heavily oxidized. And the red is iron which has been very well oxidized. In other words, 3 versus 2 valence. And that tells us then that maybe the green was formed underwater, or at least exposed to water, and the red is up above. And one theory that you could have, or hypothesis you could suggest, is maybe these are ancient soils that we're looking at. They don't have any marine fossils in them. If you break open some of the harder pieces, you find that there's kind of wispy looking things like that that have some carbon related to them, and they look like root casts of some kind of plant. And now there was no grass 275 million years ago last Thursday, as Mark Twain would add. But possibility of these as being paleosols, which are ancient soils. And so you're looking at the top of the water table when you see the contact between the lower green and the upper red. And then the limestones are definitely marine. They contain various kinds of marine fossils. So there is a gradation. And very often you find, with maybe as thick as maybe 8 or 10 feet below the limestone itself, you'll find that all green colored shale and or mudstone. And the idea then is this is the beginning of maybe a flooded area. The sea has advanced over the surface and there's no longer any free oxygen that isn't above the water. And then sometimes you find a knife edge between the lower green and the upper limestone itself. So, and that probably represents what we call a gap in the record, which may be, you know, tens of thousands of years old. And you think of how long it takes to develop a soil, for example. It takes a long time, and then there can't be very much going on. And then some kind of flood takes place or migration, and then you find immediately above the red, then you find green, and then you go up. Along the highway, just as you get onto the interstate, if you look at the shale or the mudstone there, you'll see at least 3 layers of this green and red, and that indicates 3 different paleosols. Clean it.
There you go.
All right.
Steam coming on.
CO2 coming out. Yeah.
Did you get it? So that's hydrochloric acid on limestone?
Mm-hmm. Yeah, it's a very weak solution. 1 to 8 out of the 12 normal or something like that.